Okay, so if you're looking at the note sheet proving trig identities, just as a reminder, an identity is a mathematical equation that is true for all values within the domain. So that really means we have to maybe find any restrictions with that. First question here, it says prove the following identities. Those are identities on your formula sheet. So to prove those ones, you would go back to X, Y, and R. I'm not going to spend the time doing it. What I want you to do this, I'm just going to cross this off and state the restrictions. So we're going to cross this state the restrictions on identity. So first thing you look for, are there any denominators? Nope, so there's no fractions in that. So then, are any of these trig ratios? Tan, cotan, cosecant, secant. Yeah. Okay, so this is how I do it. You don't have to do the beginning part. I go, okay, I know that tan can't be undefined. You don't want that. I know that secant can't be undefined. I don't want that. So then I go, okay, well, when is tan undefined? When cosine of theta is 0. When is secant theta undefined? When cosine theta equals 0. So I do not want that. That's how I think about it. Okay? Really, we're not going to check the work that you do to get the restrictions. It'll just be a mark for the restriction. Okay? We're not making like a whole proof out of a whole huge amount of marks. So the work won't matter. You just have to come up with them. But this is how I do it. So then I think, okay, when is cos 0? So cos is 0 at here and here. Pi over 2 and 3 pi over 2. It doesn't say what units to use, so you could use degrees in this, all right? But I'm going to use radians because more often it's in radians. So theta cannot be pi over 2 plus multiples of pi.
Have you done like a poll to see which, like, what more people write, n pi or pi n?
I have not done a poll.
Okay. What if you use n pi?
I do, but we had this discussion, as I mentioned before, in the math office. Yeah, and so some do pi n, some do n pi. It doesn't matter. And then sometimes when we were talking about it, I was going, I think I do pi n. And then when I started writing it again, like each year you do it again, it's like, oh no, I do n pi. Okay, so next one, same deal. We're not going to prove it. We're going to just state the restrictions. So there's no denominators, but I know that cotan, we do not want that to be undefined, and cosecant, we do not want to be undefined. So cotan is cos over sine, cosecant is 1 over sine, so that basically means sine theta cannot be 0. You don't have to do that. That's just the way I think about it. I convert it back to my primary ratios, right? So then sine is 0 at here and here. So that's multiples of pi. So theta cannot equal multiples of pi. Okay. So those are the restrictions. Probably on a test, if it's a written response, some questions, if we're asking you to prove, we're not going to prompt you to state restrictions. Just like a rational expression back to last year, we're not going to prompt you. It is part of proving something or simplifying a rational expression or whatever it is. We might be nice for the odd ones. Right? Remember, sometimes we might say you do not have to state restrictions. Just because we don't want you to spend the time, we want to see the proof part, and we'll do the restrictions on a different one so that we're sharing those marks between different questions.
Like that one question on the trig quiz where there was like 17 different trig ratios, then you wouldn't ask us to do like
Yeah, like we're going to keep it reasonable, right? So that we're not over marking on a certain concept of description. Okay, so now we're going to do some proofs. So that involves simplifying. You get out your formula sheet. So it's handy for you. You keep the left side separate from the right side, whether that's saying LS equals doing your work, RS equals separately, or doing a chart like I do, a T-chart. Okay? But do not keep this and do work in that equation. Okay? So I'm just going to copy out what each side is. Okay? I always look to the more complicated side. That is maybe something that has two terms, something that has a fraction. Because in this case, the left side is just one trig ratio. So I want to simplify this. Very hard to go backwards from here. So this one, nothing, sometimes in this case you could factor, but there's nothing to factor. Right now, I see there's a tan. So I'm going to express tan in terms of sine and cos. So now I actually have a fraction. That's really going to be sine squared theta over cos theta. So I want to find a common denominator here. So this is over 1. Right? So I'm going to multiply top and bottom by cos theta. Okay. So now you should see you have a common denominator. Adding the numerators, you get sine squared plus cos squared. That's our favorite, or my favorite identity. Probably will end up being yours too. Okay. Not quite done yet. We've got 1 over cos. The left side we have secant. You do need to show each side looking exactly the same. So you can either say this is equal to secant, or you could go here and do 1 over cos theta. You can do a little bit to both sides. You don't have to just take one side and do all the work. You can do a little bit to each side. Okay, there's no rules about that. You just have to keep those sides separate. Okay. So left side equals right side, so that's good. Now our restrictions. So notice there aren't any denominators here. Okay. So then yes, you can look in this, but I'm going to do what I normally do. Totally up to you. I look here and go, okay, secant and tan. I know they can't be undefined. So secant theta cannot be undefined. Tan theta cannot be undefined. Secant is 1 over cos. Tan is sine over cos, so that means cos theta cannot be 0. So just like one of the first ones we did, when is cos 0? Up here and down here, so theta cannot be pi over 2 plus n pi.
whenever it's an imaginary number.
Okay.
Whenever it's an imaginary number, then cos is 0. I think it's just an imaginary number. Right?
Yeah.
Different things.
Yeah. Okay. Next one is Okay, quiet please. If you're done, go to the next one. Don't need to. Okay, so part B, obviously the left side of part B is way more complicated than the right side, so you want to try to simplify the left side. Okay, formula sheet. Anytime you see a squared, take a look at it. So, 1 plus cotan squared is there. It's equal to cosecant squared. Theta. 1 plus tan squared is equal to secant squared theta. Okay, so you might already know that that simplifies to cotan squared, but remember this is a proof. A proof where you're using these identities. So there isn't an identity here that says cotan equals cosecant over secant. You cannot finish this. Okay? You will replace cosecant squared with 1 over sine squared, secant squared with 1 over cos squared. Okay, when you're dividing fractions, you invert and multiply. So you can now show that as cos squared theta over sine squared theta. I'm okay if you don't show that step of taking the reciprocal and multiplying, because that's a step back from elementary school, right? So I'm okay with that. Then you could say that's equal to cotan squared. Probably best form, I don't get too picky on this, but probably you should show it as in brackets, cos theta over sine theta squared, and then close it up. I'm okay with you if you want it here. And then on this side, show it as cos squared theta over sine squared theta. Okay? Or here, next line, cotan squared theta. So I'm a little bit lenient about when, if you need brackets, do your square. I'm okay with that. Okay, so restrictions. There is a denominator. So in this case, it's not going to have an effect, but we do want to think about it. 1 plus tan squared theta cannot be 0. So you want to think about that denominator. Can that ever be 0, 1 plus tan squared? No. Right? Because if you did try to solve that, okay, you can't take the root of negative 1. Right? So there's not going to be any restrictions from that. If it was just 1 plus tan theta, yeah, there would be some restrictions on that. But it's 1 plus tan squared. So nothing from that, but in the original, there's a cotan and a tan. So, this here. So, cotan theta cannot be undefined. Tan theta cannot be undefined. Well, cotan is undefined where sine is 0. Okay, so sine theta cannot be 0. Tan is when cos theta cannot be 0. So now we have 2 sets of restrictions. So think we've done actually both of them back in the first question. So when is sine 0? That's here and here. When is cos 0? That's here and here. Okay, so basically every pi over 2. So the restrictions here are n pi over 2, or pi over 2n. Okay, take a look at C. C is in terms of x, I gotta remember that. In any case, on the left side, it's one term. The right side, it's two terms. So I'm gonna think about simplifying the right side first. And secant squared, take a look on your formula sheet. If I rearrange my 1 plus tan squared equals secant squared by bringing the 1 to the right, then that right-hand side is equal to tan squared. Okay. So kind of done with, can't really do much more. You can get it in terms of sine and cos. But I'm going to go to the left side now and do some work. So sine squared can't do anything, but secant squared is 1 over cos squared. And I'll show that as one fraction. Okay, then same as the last one. You can go, if you want to, you can, I'm okay with leaving that and working on the right side. Really, you probably should show it like that, and then that's tan squared x. Or work on the right side.
As long as you can show that both sides are equal to the same thing.
Yep. You do a little bit on each side, everything on one side, depends on what you're starting with, basically.
You just can't cross over. Because then you're assuming that they're equal.
Correct. Okay, so no denominators here, but I know secant x cannot be undefined, and that's the only one, right? So that means that cos x cannot be 0. A lot of them are going to be very similar. It's really when you get a denominator that maybe, as I mentioned before, is 1 plus sine theta or 1 minus tan theta, that maybe you'll get some other ones. But most of them are going to be when cos or sine equals 0. So, we think cos can't be 0, and that's the top and the bottom. So that's pi over 2 less than pi. Yes. Oh, x cannot be 0. So, yeah. Okay, so D, left side is a fraction, right side is 2 terms. If we have 2 terms, we want to make it 1 term, if possible, but those are sine and cos. There's nothing we can do with that, right? If there's a sine squared plus cos squared, yeah, sure. Or if there was, one of them was tan or cotan, where you could reduce it down, maybe you could. So I'm not going to start with the right side in this case. I'm going to start with the left side and replace cotan and cosecant. Okay, so then you're dividing by 1 over sine, which is the same as multiplying by sine. Or you can think about it as multiplying by, we talked about this the other day, by the lowest common denominator, top and bottom. It's the same result. When you do that, you get sine theta plus cos theta over 1. Well, we're done. It's pretty easy, actually. Okay, so in terms of restrictions, there is a fraction. So cosecant theta cannot be 0. Nothing on the right. Then cotan theta cannot be undefined. And cosecant theta cannot be undefined. Can cosecant ever be 0? No, remember those cosecants and secants are the U shapes that never cross the x-axis. Okay, so this doesn't give us any restrictions because of the denominator. But then here, cotan, that's cos over sine. Cosecant is 1 over sine. So these, our sine cannot be 0. Okay, and then remember for sine, not be 0. Sine is 0 here and here, so theta cannot be multiples of pi.
I forgot what it's called. Like, since sine has zeros, obviously at 0, that means that the inverse has poles there, so it can't be, like, they can't be there.
What?
Like, cosecant can't be 0 because sine theta has 0. Like, cosecant theta is undefined, where sine theta is 0.
Okay, so we'll do one more E, and that's where we'll stop it for today. So take a look at this one. Fractions on both sides. Okay, so we've got to try to make one fraction look like the other. 2 terms in the numerator in the first one on the left, and then 2 terms on the bottom on the right. You cannot cross over, right? So this is for sure, that would be probably someone thinking, oh, I just want to cross multiply. Okay, you can't. But think about what happens if you did cross multiply, you'd be multiplying conjugates. So that's a bit of a hint. So if you have something that's a 2 terms, then think about maybe you need to multiply by the conjugate if these aren't squares already, because there's nothing in our formula sheet that we can use right now. So I'm just going to copy these out to start. Oh, I didn't turn my computer, so who knows if you can hear me. So I'm going to multiply through by the conjugate, top and bottom. I'm going to leave the numerator in factor form. Maybe, crossing my fingers, something will divide out. when I multiply those conjugates, I get 1 minus cosine squared x. Take a look at your formula sheet. Look for any formula that has cosine squared in it. So it's sine squared x plus cos squared x equals 1. That's on your formula sheet. So if I bring this over to the right, I would get 1 minus cosine squared equals sine squared. So that's going to be sine squared. Okay, don't divide out a common factor all and do that all in one step. Show it. Right? You have to basically, that's your substitution. Okay, so then one of the signs divides out and voila, you get the left side. Now, restrictions for this one are a little bit different. There are 2 denominators. So, sine of x cannot be 0. 1 plus cos x cannot be 0. There are no other reciprocal trig ratios in there. So that's it. That's what we're working with. So, when is sine 0? There and there. When is, so continuing with this, that means cos x cannot be negative 1. Okay? So for that, when is cos negative 1? Here. Okay? So we have to include, so that's basically repeated. So if you forgot about the sign, the left-hand side, and only did the restrictions for the right-hand side, you would have missed some. Right? You do have to check both. So this one gets both of those. So overall, x cannot equal multiples of 5. So sine of x can't be 0, that's both of those. Cos can't be negative 1. It's already included in the sign restriction. That's the winner. Winner. Okay. We're going to continue this on Friday. Okay, so you've got your formula sheet. Obviously, in this one, the left side is pretty simple. It's 1 trig ratio. It's a reciprocal, cotan, but maybe we don't even have to do anything with that. I'm going to copy out the left side and the right side. The right side is more complicated, so that's the one I'm going to deal with. And notice how this identity is using some of the double angle identities. So they're kind of halfway down the page, 2/3 down the page there. So on the right-hand side, for sure, for sine of 2 theta, there is only one option there. So that's 2 sine theta cos theta. For the numerator, there's 1 plus cos of 2 theta. So when I think about this one, there are 3 options for cos of 2 theta. The first one listed is cos squared minus sine squared. Okay, so then you'd have 3 terms. Nothing simplifies. The next one down the list is 2 cos squared minus 1. Well, if I replace that with 2 cos squared theta minus 1, what happens to the 1 and the minus 1? Gone, right? Added to 0. So that's the one I'm going to use. So 1 plus, what did I just say? That was 2 cos squared theta minus 1.
equals to square theta. Just simplify it.
You do need to show the substitution. Yeah. Okay, so listening please. Remember, you have to show your work as if the person reading it is not in grade 12, so maybe a grade 10 student. You have to show every step. If you think about it that way, then you're not going to miss anything. Okay, so I do need to see some kind of substitution in there. Because this, 1 plus cos of 2 theta, well, I guess you could rearrange that, right? But I would like you to put that in there. I understand what you mean, you can rearrange. But try to substitute it in so it makes it really
I
clear.
actually use the Pythagorean identity there.
Yeah, you can. You can replace this with sine squared plus cos squared, but then you still got to deal with that one.
Oh, no, I used the added unlike identity for cos 2 theta that's...
Yeah, you can use any of them. It just
Yeah, cos squared
depends how
minus
many
sine squared,
replace.
and then 1 minus sine squared is cos squared,
Right.
so 2 cos squared.
Yeah, so you're... Okay, listening please. Guys at the back, stop talking. Okay, so you can... This is not the only way to do this. You can replace this with the other forms, and then maybe you have to replace again. So it's not the only way. Remember, the way you do it might be slightly different from your neighbor. You show your steps. If you end up getting the left side equal the right side, you're good to go. Okay? So here, cos divide out. Cos divides into that one. Okay, and then you could make it equal to cotan theta there, or you could go back over here. Show it there, doesn't matter, as long as the last statement on the left side and the right side are exactly the same. In terms of restrictions, okay, so in terms of restrictions, we've got a denominator. So in the denominator, sine of 2 theta cannot be 0. So we haven't solved equations like this. So this, in this case, you might want to go look at what it to sine of, you might want to look back up here to your substitution to see what sine of 2 theta is equal to. It's equal to the product of those two. So really, this leads to sine theta cannot be 0 and cos theta cannot be 0. Next week, we'll be solving trig equations, and we'll be able to answer this right away from here. We won't have to split it up. But this gives those, so those can't be 0. That's from the denominator. Then you look back in the numerators. Are there any trig ratios that give you asymptotes, so undefined? Yes, cotan. So cotan cannot be undefined. When does that happen? When sine of theta is 0. So this leads to this one. So looking up here, that's a repeat of this. So basically, this is where we get our restrictions from. So remember, sine is 0 at 0, pi, 2 pi, 3 pi, etc. So you can do, I like to do that unit circle when it's sine 0 here and here. When it's cos 0, up here and up here. So theta cannot be multiples of pi over 2. Do you have to show work in getting your restrictions? No. I'll just be looking for what they are. Okay?
So if it's theta cannot equal pi over 2n.
Correct, yes. We've talked about that a few times. It's the same. Okay, so look at the next one. Notice there's an actual angle value in this one. So we're going to actually simplify that part of it. But this is the difference of two angles with sine. So Again, that's on your formula sheet. Kind of midway, sine of alpha minus beta. So we're going to replace the left side with that. Nothing really to do on the right side. So this is sine of beta minus pi over 2. Okay, so sine of this difference of two angles, remember, is sine cos minus cos sine. So sine of beta cos of pi over 2. And I'm just going to move this to the right a little bit. Minus, same sign there, cos, the formula sheet puts cos first. If you want to put sine, that's fine, as long as you then make sure you have the different angle. So then you can simplify parts of it. What's cos of pi over 2? What's sine of pi over 2? You substitute those values in. So cos of pi over 2 is 1. Sine of, is 0. Okay, and sine of pi over 2 is 1. So this whole term goes to 0. And you're left with the left side equals the right side. Are there any restrictions on this one? No. Okay, so those are the two in our notes. Then the exercises start. We're going to do question 5, so bottom left corner. We're going to do that one together. This is a little more complicated. It's got powers of 4. You might have space above or below or to the right. Up to you. Okay, question 5 there. Looking at those two sides, they both have two terms. You can't cross over. Well, so for example, 1 plus 2 tan squared, well, maybe you think, oh, I'm going to replace that tan of 2x or some kind of version of that, but also look at the arguments. So all the arguments, the angles, are x, not 2x. So there's no double angles in this, right? Well, what are you taking a photo of? You don't have your notes?
No.
Wow. Take a look at your formula sheet. You have no identities with an exponent 4. But on that left side, I see it's a difference of two terms that both are exponent 4. So when we have a difference of perfect squares, think about factoring. So take that left side. You can do this different ways and factor it. As I said, there's different things you can do. Maybe you replace the tan squared, but I'm going to start here. And I see that I can factor this. Make this a little bit bigger. I always look to the right-hand side or the other side. That I want, it only has two terms, but it just has tan in it. So I have some tans, but I also have some secants. So on my formula sheet, if you take a look, secant squared is 1 plus tan squared. So I'm going to replace secant squared with 1 plus tan squared, because hopefully that's going to help me get to this. So this becomes, secant squared becomes 1 plus tan squared. Here, this secant squared becomes 1 plus tan squared. Okay, and what you'll notice here is these tan squares add to 0. Collect the tan squares here. And voila, got it. Now, I think you say voila when it's magic. It's not magic, but it's not magic.
As soon as I saw like the sec or the secant, I was like, oh, I know something about it.
Okay, so that's
Because I saw that it was tan or 2 tan squared x plus 1, and I was like, then that's got to be 1.
yeah. Okay, and then in terms of your restrictions, so there's no denominators, but secant x cannot be undefined. Tan x cannot be undefined. Right, that's it. So then here, secant is 1 over cos. Tan is sine over cos. So really, cos theta cannot be 0. Right? And so cos is 0 at pi over 2, and 3 pi over 2. Oh, I guess it's not theta, it's x, right?
That's not right.
That's not right.
What cosine is not at pi over 2 cosine is not 0. Oh wait, sorry, cosine is 0. Sorry, what am I doing? Yes, sorry.
Like, couldn't you do 10 pi over 2?
No, it can be.
No, because we don't have these.
Oh.
Okay, so that's a little bit harder one when there's powers of 4. I think there's, actually maybe that's the only one there. Okay, but yeah, so rest of the period is a work period. Okay, saying that, the work periods that we've had lately, the review and the day before that, way too loud. Okay, stay in your seat. You can survive. You all know your neighbor, okay? And whisper. I want to end the day in peace.